The ninth question that we have is a very important and a very conceptual problem. It is given that a sound source is moving in a circle of radius 3 meters with angular velocity is equal to 10 radians per second. It is also given that a sound detector is located far away along this line and is performing SHM with amplitude 6 meters about the point C and the frequency of SHM is given and the frequency of sound emitted by the source is also given. Velocity of sound is given. We need to find out the maximum minimum frequency recorded by the detector when it is given that initially sound source is at A and detector is at B. Now this question can be very easily solved if you remember all the formulae and you analyze the data very properly. So let us see that let us find out maximum frequency. For maximum frequency, we know the formula lambda f is equal to V. Therefore f is equal to V upon lambda. Therefore for maximizing the frequency, V should be maximized and lambda should be minimized. Now we have the observer over here. Therefore this is the velocity of sound with respect to observer. This is the frequency observed by the observer and this is the wavelength observed by the observer. Because we know that lambda observed into f observed is equal to velocity of sound with respect to observer. Therefore we must try to maximize V and minimize lambda. Now let us first make an attempt towards minimizing lambda. Now we know that when a sound source is moving away from an observer, then the lambda is minimized. Or sorry, I said totally the opposite thing. Whenever the sound source is moving towards the observer, then the lambda is minimized and is equal to V minus Vs into T. So let us find out when is the sound source moving towards the observer. Let us take the case when it rotates an angle of 3 pi by 2 and is at 3 point with its velocity in this direction. Now this Vs will be equal to, at this point of time, Vs will be equal to omega r, that is equal to 10 into 3, that is equal to 30 meters per second. Now let us find out the time taken by A to reach here. Omega is equal to 10 radians per second. Therefore the time taken by the source to reach this point, let this be B or rather P. This will be equal to 3 pi by 2 radians upon 10. This is equal to 3 pi by 20. Now let us check what is happening to the observer or rather the detector in this much time. The frequency of SHM is given to be equal to 5 upon pi. Therefore time period is equal to 1 upon frequency is equal to pi by 5. This is equal to 4 pi by 20. Now if you know all the properties of SHM, you can solve it very fast. We know that in an SHM a particle reaches from extreme position to the equilibrium position in time t by 4. So in t by 4 time, that is pi by 20 time, the detector moves from B to C. In another t by 4 time it moves from C to D, and therefore in 3 pi by 20 times, that is 3 t by 4, it comes from B to C, C to D and again from D to C and having a velocity in this direction. Now the beautiful thing is that we see that we have also maximized V after the time 3 pi by 20. This is because when the detector has velocity in this direction, then the velocity of sound with respect to the detector will be maximum, because this velocity will be added up in the velocity of sound. Therefore we have done two things at the same time after time t 3 pi by 20, that is we have minimized lambda and maximized V. Actually the velocity of sound source should be in the direction of the observer so as to minimize lambda, but since this is located very very far away, therefore this can be assumed to be a straight line. Therefore the maximum frequency can be written as velocity of sound with respect to observer at this point, that is equal to velocity of sound plus the velocity of observer, that is 330 plus a omega, because this particle is executing as SHM and is at its equilibrium position, and the maximum and the velocity of the observer is maximum at the equilibrium position, and that is equal to a omega. So this comes out to be equal to 6 into omega, that is 2 pi f, that is 2 pi into 5 by pi. This comes out to be equal to 330 plus 60, that is equal to 390 upon, we have not yet calculated the denominator. Now this was the velocity of sound with respect to observer. Now we need to find out the wavelength with respect to observer. We know that since the source is moving towards the observer, the velocity of the wavelength will be equal to v minus vs into t, that is equal to v minus vs into 1 upon f, that is 390 into f upon v minus vs. Now on substituting the values over here, we get this is equal to 390 into the frequency of source, that was 340, upon velocity of sound, that is 330, minus velocity of source, that is equal to omega r again, that is 10 into 3, that is 30 again, therefore we write this as 300. This becomes equal to 13 into 34, that is equal to 442 hertz. So our answer for maximum frequency comes out to be equal to 442 hertz. Now let us find out the minimum frequency. We have maximum is equal to 442 hertz. Now we need to find out the minimum frequency. We know that f is equal to v upon lambda. Therefore we again now need to minimize the velocity of sound with respect to observer and maximize the wavelength with respect to the observer. So for this, let us first try for the maximizing the wavelength. So let us check this point, that is at pi by 2. Now at this point, the velocity of source is like this. Now whenever the source is moving away from the observer, then the wavelength is v plus vs into t, that is the wavelength is maximized. Therefore let us take at that point the time taken by the source to reach from here to here is pi by 2 into 10, that is equal to pi by 20 seconds. So after pi by 20 seconds, the source is moving in this direction. So let us check what is happening over here in pi by 20 seconds. We know that t by 4 is equal to pi by 20 for this one, SHM. Therefore in pi by 20 seconds, the observer is at the equilibrium position and it is moving in the right direction. So we have done two things at a time. The data is such that we are maximizing the wavelength as well as we are minimizing the velocity of sound with respect to observer, because when the observer is moving towards the right direction with its maximum velocity possible, in that case only the velocity of sound with respect to the observer is minimized. Therefore on solving this, we get f minimum is equal to velocity of sound with respect to observer, that is 330 minus a omega, that is equal to 6 into 2 pi into 5 upon pi upon the wavelength, that is equal to v plus vs into t, that is 330 plus velocity of source, that is equal to omega into r, that is 30 into t, that is 1 upon f. The frequency is given to be 340 hertz. On solving this, this comes out to be equal to 255 hertz. So our final answer for the minimum frequency recorded by the detector comes out to be equal to 255 hertz. So final answer is 442 hertz is the maximum frequency and 255 hertz is the minimum frequency.